Okay, let's go ahead and get started. Hello, everyone. My name is Marcy Samuelson, and I'm Marketing Manager for the Developer Initiative here at Oracle. Thank you for attending today's webcast, Build Cloud Native Applications on Oracle Cloud Infrastructure. We are very excited to be able to share with you how you can build and deploy a microservice-based application on Oracle Cloud Infrastructure using the Oracle Cloud Infrastructure Container Engine for Kubernetes. If you have any questions during the workshop, please put your question in the Q&A area, and we have a number of experts on the call who will answer your questions as quickly as possible. In addition, if time allows, we will answer questions live after the presentation. This webcast is being recorded, and we will make it available shortly after the webcast concludes. Again, thank you for joining the Build Cloud Native Applications on Oracle Cloud Infrastructure. This webcast will be presented by Manish Kapoor, Director, Oracle Cloud Platform for Application Development. At this point, I will turn it over to Manish.
Thank you, Marcy. Hello, everyone. Thanks for joining us today and taking the time and joining this webcast today. So I will be giving you an introduction to Oracle's Cloud Native Application Development Platform today. And then if we have time, I'll also show you a demo how to build and deploy a microservices-based app connected with our Oracle database. So my name is Manish Kapoor, as Marcy said, and I'm from the OCI product management team. I've been with Oracle for about 10 years now. And over the last 3 or 4 years, I've been focused on OCI and especially in the DevOps and the cloud native application development side of things. So let's get started. So as usual, here's a safe harbor statement. So the agenda for the day is I'll talk about, set the context by talking about what's happened in the application development world over the last few years. What's cloud native application development for those who are new to cloud native application development. Talk very, very briefly about Oracle Cloud, and then talk about get into the main topic, which is cloud native application development using OCI. And I'll talk a little bit about cloud native application development when it comes to microservices and data management, and what Oracle thinks and what's our viewpoint in terms of how you should build and deploy microservices when there's persistence involved in terms of databases. And then we'll do a quick demo, and I'll give you some pointers to resources where you can try some of the things that I talk about today and learn for yourself. So let's get started. So if you look at the early days of computing, applications were built and run on physical servers. Next, after that, we saw the emergence of virtualization and started seeing a consolidation of servers and better utilization of resources when virtualization was used. In the cloud computing era, which actually started 15 years back in about 2006, it was all about distributed and elastic computing for applications. Containers and serverless further exploit the benefits of cloud's distributed and elastic computing properties. This shift, if you see from physical to virtual to cloud computing to containers to serverless, is all about making the developers more agile and productive and having them focus on writing the code, application development, doing application development and writing the code rather than worrying about the underlying infrastructure. So you want to spend your time efficiently as a developer, not spend time setting up the infrastructure below. So that's the way the world has progressed. Now let's look at how development and deployment has happened over the last about 20 years or so. If you see, starting with in the 80s and the mid 90s, there were data centers with physical servers running monolithic applications developed using traditional waterfall methodologies. Then going into 90s and up into 2000s, data centers and hosting providers were running Linux and Unix servers with virtual machines and using VMware or KVM and running 3-tier or N-tier applications that were developed using agile methodologies. And then finally, now we are in the 2010 onwards timeframe. In the last 10 years, we are seeing the evolution of cloud native development, right? So cloud has been increasingly being used by customers for writing and building and deploying the applications. And most of the modern applications that are being developed today are running as microservices on containers. Developers and operation teams are actually collaborating using DevOps methodologies. And in fact, we are also seeing the move to serverless functions a lot in the last 5-6 years, where we are seeing we are moving from a DevOps to a no-ops kind of a model. So you don't want to do any operational work as far as the underlying infrastructure is concerned. We are seeing a new generation of applications that are born in the cloud and will be run only inside on cloud in the cloud model. These are the cloud native applications that follow the cloud native computing foundation's principles. So, as I said, CNCF or Cloud Native Computing Foundation is where all the cloud native application development projects are happening. This is a place where all the open source projects related to cloud native application development happen. They are sustained there. It's a foundation under Linux Foundation, and there are several members in that. Oracle is a platinum member of the Cloud Native Computing Foundation. Cloud Native Computing Foundation put together a trail map which shows the recommended process for leveraging open source technologies to build cloud native applications. So let me walk you through the quick steps as to what CNCF says how to build cloud native applications. So there's 10 steps in all, and these 10 steps are not mandatory for building all cloud native applications, but it's just a trail map. It's just a guide for you, a reference point for you as to what you should think through when you're building the applications. You start with containerization. So you build your applications as Docker containers most commonly. You have a CI/CD approach where you use some DevOps tool chains to continuously integrate, build, and deploy your applications that you build inside the Docker containers. And then once the application has been built and packaged as a Docker image, it is run inside an orchestration engine. And the most commonly used orchestration engine is Kubernetes, right? It maintains the lifecycle of your cloud native applications. The fourth part is once your application is deployed, you should have tools and ways to observe and analyze and debug and trace your applications as they run in the production environments. So there's a set of tools like Prometheus, Grafana for monitoring, Fluentd for logging, and Jaeger for tracing, which are incubating in the CNCF Foundation, which help you observe and analyze your applications once they have been deployed. Next, when you start using microservices, you may think about using service mesh. Service mesh is basically helps with managing your microservices deployment, doing service discovery, health checking, routing, load balancing between microservices. All that functionality is provided by service mesh. And the common ones are Linkerd and Istio and some of the other service mesh which are coming out. So you may or may not need a service mesh, but typically in most of the cloud native applications, you do need Docker containers, you do need a CI/CD foundation, you do need Kubernetes for your orchestration, and you do need some kind of observability and analysis tools. And then rest of the things which we talk about here are optional and dependent on your project. You may want to use a different networking protocol than the default provided by your Kubernetes orchestration system. You may want to use Calico or Flannel or something else. In that case, you have to look into the CNI part of it. If you are using databases with your applications and you're using distributed databases, that's another thing which you want to factor into when you develop your applications. Messaging protocols, container runtime, and software distribution are some of the other things you want to factor when you take start your journey of building cloud native applications. So now for each of these 10 steps, there are several open source projects which are going on in the CNCF community. what you're seeing is quite an eye chart. In fact, one of the most complex eye charts I've ever seen. You're seeing about 880 plus CNCF projects, which are happening in the CNCF Foundation. These projects are basically show a landscape of all the technologies that are available to you as a developer for building and deploying and managing and orchestrating your cloud native applications. As you can see, it's a very daunting task. If you are new to cloud native application development, if you look at this trail map and if you look at all these projects, you will feel lost in the beginning. If you see the projects, which one to pick up, what should I use, what should be the right one, should I use multiple projects or should I just pick one and run with it? What happens if it doesn't meet my needs? So the decision of using a project is left to you as a developer, and which I think is a daunting task for most developers. So there are many routes to deploying and building cloud native applications. In fact, let me tell you, I'm sure you may not have known, but there are over 47 certified Kubernetes distributions, Kubernetes providers out there in the market. So choosing a Kubernetes provider itself, you have so many choices. So and then when it comes to the data management part of cloud native applications, that is also a very tricky challenge. It still is a tricky challenge, although we have made some progress here. When it comes to data management, again, CNCF has a whole series of database solutions out there for you to choose. There's an ever increasing number of choices available to you. Most of these vendors provide you with Kubernetes operators that deploy their databases into Kubernetes clusters that you manage in addition to the applications that you're building and deploying. Right? If you think about containers, Docker containers, when they were originally came into the existence and became popular, they were used for stateless applications. And now we are seeing we are seeing use of containers for stateful applications and being used for persistence and database tier as well. This can become a complex deployment for you still, although we have made progress, like I said. But it is still a challenge to have persistence tied to microservices. And I'll talk a little bit more about why that is the case as we move along. So let's talk about Oracle Cloud very briefly. For those of you who are new to Oracle Cloud, we have 29 commercial and government regions all over the world. We have hybrid cloud strategy, as well as an Azure interconnect, where we have a high-speed network, direct network connection into the Azure data centers. And on top of this, on top of these infrastructure regions that we have globally, all over the globe, we provide you services, platform services, as well as software as a service applications, as well as data management services. So we have developer services and the DevOps services on the left. And then we have the data management services, which is all about the Oracle database and data management technologies that we have, including AI and ML and things that operate on top of data. We have SaaS applications, we have analytics, and we have tools for governing and securing the entire cloud applications. So it's an end-to-end set of services that we provide. Today, however, we'll focus on the cloud native application development. And here's a drill down, a one step deeper look into the block diagram that I previously showed. So as you can see, we have a pretty rich set of services for application developers, for data management, for infrastructure tasks, and for governance and observability when it comes to security, governance, managing and monitoring your applications. As well as we have got a series of SaaS applications that sit on top of the same infrastructure as a service. One thing unique about Oracle Cloud is everything that you see in our public cloud, all the services that you see in our public cloud are available to you in your data center also. We have a product called Dedicated Region Clouded Customer, which is basically a complete copy and paste of our public cloud services running inside your data center. It's a smaller footprint obviously, but assuming you want to run cloud services, cloud deployment model, use a distributed computing model, but you don't have a public cloud region in your country, or if there's a need for having your cloud services in your data center because of data residency needs, or because of proximity needs, or because of compliance needs. So we are one of the only providers in the market today that gives you the same cloud, public cloud in your data center as well as in a public cloud model. So I just talked about it. So we have 3 deployment choices. You can deploy some parts of a cloud in your data center, like your Oracle database is same whether it lives in your data center, in the public cloud, or another public cloud, or in Oracle public cloud, and in the cloud at customer, right? So we have 3 deployment choices. You can deploy it on premises, you can deploy in the public cloud, and you can deploy in the cloud at customer model via the dedicated region cloud at customer, which basically is a copy and paste of our public cloud services. So that was a quick overview of the Oracle Cloud. So let's talk about application development and deployment. In particular, we'll talk about building and deploying and managing and monitoring cloud native applications on Oracle Cloud. So if you look at it, like all providers, we have a strong second generation. We have a set of cloud infrastructure services. Ours is, we are a little new in the market as compared to AWS and Azure, but our cloud is a second generation cloud where we offer, bare metal servers as well as virtual machine servers. We have things like off-box virtualization, which lend to superior performance, and because of which we can guarantee performance and give you SLAs on performance as well for our cloud for the compute infrastructure. On top of this compute infrastructure, we have the developer tools on the left side. We start with the left side. We give you a set of prescriptive tools. In our case, we have a platform service for you to build and deploy your services applications in Oracle Cloud. It's called Visual Builder Studio, and we'll use that today in my demo. We have Resource Manager as a service, which is based on Terraform, which lets you orchestrate all your underlying compute infrastructure and all your application stacks. And then, of course, if you're already invested in tools like GitHub, GitLab, Jenkins, or any of the existing CI/CD tools, you can bring those in as well on the Oracle Cloud and run them as it is. Or you can integrate with our Visual Builder Studio some parts of your existing DevOps toolchain. Once you have your set of developer tools ready, the next step as a developer is you build applications. And when you build cloud native applications are typically polyglot in nature. By polyglot in nature, I mean you can use multiple programming languages to build different microservices or different serverless functions. So you can choose Java for running one type of microservice application. You could use Python for writing, or Node.js for writing another part of the application. You could use React.js or C# for writing another part of the application, right? So you have a choice of picking up the language and the framework that you want to use for your application, and build that application inside using the developer tools that we offer. Once the application is built, it is deployed into a Kubernetes environment, or if it's a serverless function, it's deployed into the Oracle Functions platform. And then you basically, the Docker images that you create are stored in a container registry, right? And then if your application has persistence tied to it, it has autonomous, we offer you Oracle database, obviously, for your persistence layer. Autonomous database is a flagship product there. We have a MySQL-based service that can let you, that can be used for the persistence of your cloud native applications. Or you can bring in any of the application databases that you like MongoDB, Cassandra, Redis, or Postgres. Any of the databases can be used on the cloud infrastructure platform based on your needs, right? And we'll talk a little bit more about data management and what you should think about when you start your microservices journey. Once you have built and deployed your applications, you always want to secure them and keep them secured, and monitor them and manage them and trace them and make sure everything is going fine, right? So we have a set of security and management tools to help you do that. So as you can see, as a developer, we give you, as a DevOps person, we give you everything from developing to operating your applications to managing your applications, including the data management tier that you may need for your applications. So this is, again, a slightly different view of what I talked about. So as a developer, you come in, you build applications using any of the frameworks shown on the top of the slide. You code your application, you build it. Once you build it, you create a Docker image out of it. You store that Docker image into a Docker registry. And from there, you deploy it into an orchestration engine, which is Kubernetes, which is in case of Oracle, it's called Oracle Container Engine for Kubernetes, OKE, and we'll talk about that. And then once it is deployed, you test your application and do some integration test, load test, whatever test you need to do. You secure it by scanning the Docker images and other tools that we have using Identity Cloud Service and Cloud Guard, and make sure you follow the security principles that you have in place. And then you monitor it, and if there's any bug or anything, performance issues, you go back to fixing your code, and it's an iterative cycle. It's an end-to-end set of DevOps tool cycle that you go through to manage and maintain your applications. So here's a drill down of the application services that Oracle offers, and in addition to the building, deploying, and operating your applications, we also get you enabled to do all those things, right? We have a cloud free tier where you can start and build and use all of these things which are there on the right side. You can build applications, deploy them, operate them using the cloud free tier. Of course, like any other provider, documentation and APIs and SDK and all that CLIs are available for everything that you do in the cloud. In addition to that, our team has been building reference architectures and solutions for you. And I'll show, if I get a chance, I'll show it to you. But otherwise, the links are provided at the end of this deck. We have reference architectures and solutions and a developer resource center for you, where you can get started really quickly. We have some tutorials, we have reference architectures, we have some, whatever I'm doing today, you should be able to do it on your own after this. So in terms of building and deploying, developing, we have a DevOps CI/CD toolchain, which is the Visual Builder Studio, which I'll be using today in my demo. Cloud Shell is there as another developer experience tool, usability tool, where you can get a quick Cloud Shell shell environment, Linux shell environment to run all your developer command lines. And I'll try to show you this part as well today. Resource Manager is Terraform-based service that lets you orchestrate your infrastructure as a code. And then we have the Docker registry, which is called the Container Registry, which is a standard Docker V2 compliant registry. So those are the components, essential key components, and there are some more things in that block, but I'm calling out the key ones. You use those to build and develop your applications. Then you can deploy them either into a virtual machine or a Kubernetes engine or a serverless function. And you can install, if you have multiple services, multiple microservices, you may need a service mesh. You could install Istio or Linkerd on top of Kubernetes. And then we have API gateway for exposing the APIs for your applications. In terms of operating your applications and supporting services, it's not just operating in that bucket. We have things like cloud events-based event service. So serverless functions get triggered by events. So we have an event service which is completely cloud CNCF compatible based on cloud event standard. Log analytics, email, operational insights are some of the other ancillary services that you may or may not need for your development work. And then we have the APM as the Application Performance Management Service, which will help you manage and monitor the performance of the applications. And then we have a whole bunch of security services to secure the whole infrastructure. And just to cover each of these services, I can spend an hour, but this is an introductory session. So I just want to make sure everybody's aware of what we have to offer. And what we are showing is some parts of this portfolio today. And we're talking some parts of this portfolio, not an end-to-end set of services. So, Oracle also has a whole rich set of partnerships for the cloud native world, for the cloud native developers in all areas, whether it's security, whether it's federation, whether it's observability, whether it's the CI/CD part of it, or whether it's the data management solutions. And we have listed some of them here on the slide. So if you have already invested in, let's say, if you have multiple Kubernetes distributions that you're using and you want to manage them, you could use a tool like Rancher very easily to manage Oracle's Kubernetes engine, as well as some other distribution that you're using. If you're using Grafana already for managing your cloud native workloads, you could very easily integrate it with our Kubernetes engine and continue using it. So the idea here is we give you a choice, and we want you to use the tools which you're already using. And if you're already familiar with it, if you already have skill sets with GitHub or GitLab or JFrog, if you're already invested in it, we want you to bring those in on Oracle Cloud Infrastructure and use them along with our technologies and our products, right? It's kind of an open platform based on the CNCF standards. We use the standard open source Kubernetes distribution, use the Docker compliant registry, which is Docker V2 compliant, right? Our CI/CD tools support Git, GitHub, GitLab, all the common source code repositories. So the idea here is to give you choice and give you the option to pick and choose what you want to use in terms of development and deploying your applications. So let's talk about microservices and developing microservices and how they compare with monolithic and some of that. So my mom said, always says that you should share everything. It's sharing and is good. Sharing is actually caring for each other, right? But if you look at the microservices versus monolithic world, we are kind of, the microservices are not believing in that sharing philosophy. If you look at monolithic applications, they are a single giant big monolithic app which shares everything. Everything must be deployed inside a single app. There's typically one database for the entire monolithic application, whereas in case of microservices, nothing is shared, they're decoupled. Each microservice has its own data store as per most architectures that I've seen out there. You can deploy microservices independently. They're small functions of your total set of application, right? They're individual functions within your larger set of business application. So there are pros and cons of doing both. And while world is moving towards microservices, I think we'll continue to see both kinds of application development paradigms. You will have monolithic applications, you will have the n-tier applications, you will continue to see growth in microservices and serverless applications as you move to the cloud, and it becomes simpler and easier for developers to adopt it. And that's what Oracle is trying to do. We are trying to make your microservices and CNCF trail map journey easy by providing you the set of services which we think will make your life easier and simpler and make it more efficient for you to adopt your cloud native journey. So let's focus on this part here. Monolithic applications have one database for the entire application. That's the typical way it has been, right? In the microservices world, there are different patterns, but the most common pattern out there is that each microservice has its own data store. While this paradigm and this pattern has its advantages, it has also got some challenges associated with it. So let's say you have 4 microservices here, right? I have the microservice, the first one, which is using a document DB, second one using a key value DB, third one using an analytics database, and the fourth one using a relational database. When you have 4 microservices, and potentially these could be written in different languages or same language. You could have it in Java, Node.js, maybe a Micronaut-based service, or something, right? You could have 4 different runtimes for applications, or you could be running it in one runtime. And you could have 4 different database types, right? And these could be, one could be Oracle, one could be MongoDB, the other could be Postgres, the other one could be NoSQL, some NoSQL database. So you could potentially have 4 different databases. And this approach works fine. There's no issue with it. Customers have used it if there's 4 or 10 microservices. But I've seen customers over the last 5 years who have taken this approach of using the best database for the best needs and then going down this path. But what happens when you have 50 microservices 5 years from now? Or what happens when you have 100 microservices 10 years from now? You may eventually end up with dozens of, or maybe 20 or 30 different database types for your microservices application. And what that leads to is complexity in your architecture. Complexity associated with data sharing between databases, data integration, management of your databases, security of your databases. you need to have skills to manage those databases. Every database requires a different set of skills. High availability and design considerations for you. And then you get a sprawl problem where you have so many things and so many different things running all over your environment that it's difficult to manage, and it can become a nightmare for a smaller set of company or a company with limited resources, right? So while this approach works for smaller set of microservices, in my opinion, the moment you go into 50, 60, 100 microservices, it becomes complex and it becomes challenging for you, not only in terms of your skills and technology, but also in terms of cost of managing the whole deployment. So you should think about your strategy when you start your microservices journey. So what Oracle is saying is you should have a mix of that strategy. We have a database, Oracle database, which is now a converged database starting from 18C onwards. We are making effort to make the Oracle database a converged database. And as you go starting from 18C to 19C to 20C to 21C, you will see us adding more and more converged database capabilities in the Oracle database. So what the idea behind that is, instead of having one separate database for each data type, you can have a multi-model database, which will be able to store JSON as well as a relational database, as well as graph DBs in the same database, right? And if you still have a need for a specialized database, you can still have that. If you still need to, for example, use MongoDB for a particular application, you could use that. But the idea here is not to have one database for every microservice. Instead, try to use converged database as a first choice for your microservice, if it makes sense. If it doesn't, then go towards the specialized database like a MongoDB or a Cassandra or whatever your choice is. But look at a converged database option first and foremost for a microservices strategy, and then look at using a specialized database so that you can reduce all of that things, the sprawl, the challenges of managing and maintaining different databases. So converged databases help you, like Oracle database starting 18C, is help you manage any data type inside the same database. It can be used for both OLTP and OLAP applications. It supports machine learning. This Oracle machine learning is embedded and part of the autonomous database and part of the Oracle database. So you basically have data and machine learning sitting right next to each other instead of having separate tools and separate things. So it makes a more efficient engine when it comes to machine learning, because machine learning happens on top of data. And if machine learning is happening on top of the database itself, is the most efficient execution engine, in my opinion, right? And then with autonomous database, we also take care of using the machine learning for tuning, securing, and managing your database so that you don't spend time managing your database. You rather focus on building your applications and deploying those applications and using those applications. So this is how we simplify the journey, which I talked about. Instead of having multiple self-managed databases, we simplify the journey by using microservices, using one autonomous transaction processing database in this example, which is running Oracle Database 20C. Or it could be one autonomous database, Oracle database, and Cassandra, or Postgres, of one other database that you need for some other microservice. But the idea is, if you see on the right side, you still have different data types for each of your microservice applications, and you still have a pluggable database for each of your microservice. You still have separation. You still follow the guidelines which microservices states that each application should have its own database. We have each application here has its own pluggable database running its own data type. But the idea is you're using one database, so it's easier for you to secure it. It's easier for you to manage it. It's easier for you to integrate data between them. All kinds of security issues, challenges related to managing and monitoring these databases become much more easier for you to take care of. And this is something very important, especially if you have plans to grow to 50 or 100 or 60 or adapt microservices architecture in a big way in your company. So let's look at creating and deploying cloud-native applications in Oracle Cloud Infrastructure at a high level. So as a developer, you come in, you code write your code for your application, submit your code to GitHub or any of the Git or any of the source code repositories. There's a CI/CD toolchain which is there. In our case, we'll be using Visual Builder Studio, which will build the application into a Docker image, test it, and push it out to a Docker registry, which is the cloud infrastructure registry. This can be a Docker registry, can be anything. It can be Docker Hub. It can be Oracle's cloud registry. It can be Microsoft's cloud registry. It can be any Docker compliant registry. You can push the images to wherever your Docker registry is. And then once the image has been pushed, it will be deployed into a Kubernetes runtime orchestrator as a container, as a microservice running inside the container, inside the Kubernetes pods, inside your Kubernetes cluster, right? And then if you have persistence associated with it, in this case, I'm going to use autonomous transaction processing database, Oracle database with multiple pluggable databases inside it, supporting different data types as a converged database there. So you have the complete CI/CD toolchain here and the runtime environment here. What I'm not showing here is the managing, monitoring and observability solutions, but that will take time, and we only have an hour today. So let me show you how this all works and step out of my screen here and share my desktop. If you're not familiar with Oracle Cloud, I'll kind of quickly show you some of the core concepts. So before we go to okay, let's look at it. So here's the Oracle Cloud infrastructure, my instance, and it's a live instance. I'm going to do a live try and do a live demo here, keeping fingers crossed. So in here, I have all the services that you would expect: the database services, the compute, block storage services, and under the developer services, I have the Kubernetes environment and the serverless functions and things like that. So here, if I go to the Kubernetes clusters, I have the container registry, which is the Docker registry, the serverless functions, API, some of these developer services live here. So if I click on the Kubernetes clusters here, I can create a new cluster, and creating a new Kubernetes cluster is extremely easy. So you can do a quick create or a custom create, and you can decide how you want to create it, and launch the workflow and just fill in a few attributes, and you can pick up the version. You can decide whether you want public worker nodes or private worker nodes. You can choose your shapes on which you want to do. One of the differentiators for us, which I think now AWS also offers, is we can have node pools for Kubernetes running on bare metal servers as well as virtual machines. I don't believe Google offers it yet, or Azure offers it yet, but eventually they will catch up if they're not there yet. But here, we were the first ones to give you a choice of picking up node pools for Kubernetes running on bare metal servers as well as virtual machines. So what is the use case for bare metal servers as node pools? It's basically for highly compute intensive workloads or your machine learning models that you want to deploy and train. You would run on bare metal servers versus virtual machines and remove the overhead of virtualization from your virtual servers. So you can choose the number of nodes and you can distribute them over different availability domains. So I'll not create a cluster here, but it's pretty easy to create a cluster. And you can do anything that you do in the UI using REST API or CLI as well. So I have two clusters here, cluster 1 and cluster 2. Cluster 1 is what I'm using. So this cluster has actually, is running version 1.17 of Kubernetes, and there's an upgrade available. So I can easily upgrade it. Just click on this and click upgrade, it will upgrade it. And it gives you all the information about the cluster and how do you access the cluster, how do you get the kube CTL going, how do you get the kube config files, everything is available for you. This cluster has got node pools. I have two node pools, node pool 3 and node pool 2. Each node pool has got 3 nodes, and these nodes are spread over different availability availability zones. Okay, so that's the cluster which I'll be using, the cluster 1. And here's an application which I've already deployed in my Kubernetes cluster. This is a microservice application. It's called, if you see, you can see it's called A1 Sales Store. And it's basically a running application. Let's make sure it's running, and I have the network connection here. Yeah, so here it is, and I can verify that it's working. Yeah, so this is basically a eBay-like application where you can users can come in and sell their stuff. Like here, this Jay Leno is selling an iPhone 6 for $600, and users can come and register their account, log in, and start browsing stuff and putting their stuff for sale and buying stuff. It's an online store, and it is running. And all the data for these, this application. This is a Node.js or JavaScript application, microservice application running inside Kubernetes cluster, and this is the working IP. It's actually publicly exposed, so you should be able to hit it if you want to. And I have the data persistence for this application inside Autonomous Transaction Processing Database. Okay, so now what I will do is I will make a small change in this application, and we will see how the CI/CD pipeline gets triggered. But before I make the change, let me show you the CI/CD tool that we have. So it's called Visual Builder Studio. Visual Builder Studio is the CI/CD service that Oracle provides in the cloud. So what you do is basically you come in, you set up your Visual Builder Studio. As an organization, you would have projects within your organization. So in this case, I have 4 microservices, which are 4 applications that my organization is building. I have a ATP microservices ATP application, which is what I'm going to use. I have another DevOps, and I have a simple application and a soft shop application. So I have a total of 4 projects in my application, in my organization. First time when you set up this tool, you need to specify the user credentials for your tenancy that you'll be using, the OCI cloud tenancy. And then you need to define the templates, build templates that you'll be using for building your application. And when you create a template, you can specify what packages you need to build the application. For example, now I'm building the one which I'm using today is a Node.js application. So I will need, the runtime components for that, as well as Docker CLI and things like that, right? I need a Docker CLI. I'll need, if I'm running Java, I'll need the Java runtime on my build template. You create a virtual machine is where your build servers build your application. And you can create as many build machines as you want. So that's how you set up the project. So let's look at my microservice application. So in here, when you log in to the project home for the microservice application that we are using for the demo, on the main screen, the project home, you will see announcements. If you want to make any announcements for your team, you can do that. And if you can see the recent activities of what happened. Right, so you see, I did some changes earlier today morning, and now I'm going to run some more changes, do some code changes for my application, and redeploy it using the CI/CD tool. So here I have all the activities that happen in the project. If somebody is working, it's a joint collaborative tool, right? So you could have 5 developers working on it, and each developer building his application or checking in code and doing various things. So this is where you see all the track of your activities. I'll not go through everything, but I'll show you the key parts of this platform service. Here is where you have all your source code for your application, right? So my YAML files, my JavaScript files, everything is in here for the application that we're using today, which is the one the A1 Sales Store, which I talked about. If you're using external Docker registry, you can obviously configure that. Yeah, I'm not using external registry, I'm using Oracle Cloud Registry. And then you have the builds. So you can create build jobs for your applications. So if you create a build job, you can specify the name of the job and then use a template the build template that you want to use for building the job, which I talked about earlier, right? So I have already created build jobs for my application there, and there's a build pipeline. In my case, my build pipeline is whenever I make a source code change in my microservice application, create a new Docker image, which is the first step. In my case, it's a Node.js application. So as soon as I change this application, the first step of the build pipeline is create a new Docker image, push it out to registry. And then the second part is once it is in the registry, deploy it into Oracle Kubernetes engine where my application is running. right? So these set of steps will be followed when I do the demo today, right? And then you can have environments. You can have a QA environment within this tool. You can have a production environment and decide where you want to deploy your application. So you have the concept of environments. And then you have issues where, as a team, your 5 people are working on this project. They can report issues and assign issues to one another. And once you have fixed them, you can go and update the issue and say it is resolved, or it is, I'm working on it, and things like that. And then you have snippets and wiki, where wiki is a place where you can collaborate for your project. You can have it's like Confluence like wiki, where you can write notes and exchange notes and share some information across the team. Snippets is where you share code snippets with the rest of the team. Let's say there's a certain set of, in this case, it's a hello world example. If you want to share the snippet with rest of the team members, you can put it here, right? And then you can share it, or you can keep it for yourself. Then you have project administration, where you can manage your project in terms of properties of the project. You can see the usage of each of your projects. So for example, this microservice project takes, it's using 6.5 megabytes of the build space. It gives you all the information about your usage of this, usage metrics of your project, right? So you can see all of that in this. So let's come back to the project home. And let me open up a terminal window here. So as I said, this is my application here. I'm going to make some changes here, and I'm going to do some live changes here. So can you see my screen? Let me see if I can make it a little bit bigger. Actually, I think. Let me not waste time. We have just 10 minutes left. So here's my project. Here's my source code for my project. I have the SQL files for my database. I have the server.js for my JavaScript file. I have the index.html. So I'll make 2 changes here. I'll change the index.html for this page and make a simple change. I'll call it, it's currently saying A1 sales store. I will change this to sales demo, the name of the page. And I will also change you see the logo here, which says A1. It's got a O in a red color. One of the change which I'll make is I'll change the logo to a different logo. I don't like this logo. I'll change it to something else. So I'll say new logo to logo. And then once I make this change, I will use the standard git commands. And this is my local desktop, and I'm a developer. I could perhaps use the IDE too, or I could use it, since I'm making a simple change, I'm just doing it in the command line. But I can make the change, and then I can basically push that. I can commit the change and then push the change. So I'll say update index and logo. So you git commit the change. So what it is doing is I'm committing the change that I made. Okay. And then I'm going to say git push. What will happen is the changes that I made in my local repository get pushed to Developer Cloud, the Visual Builder Studio Git repository, which I showed you in the Oracle Cloud console. So you can see that this has connected to the Oracle Cloud and pushed out my source code to the Developer Cloud service or the CI/CD service here. And as soon as I do that, I should see here, well, should have picked it up on its own, but I guess as soon as I pushed out the code, you can see that it's kicked off a new build job, right? So here's my code change, which I said. I pushed out, I said update index and logo file, right? So I'm updating that, which is just now. And as soon as that happened, I have a trigger set to watch out for code changes. As soon as a code change happens, rebuild my application. And when it rebuilds this application, it's basically going through this build pipeline. So you can see that it just now finished creating the new Docker image. And now the second step, it's deploying to OKE, and it just finished deploying it, right? So if I look at the Docker, these two build jobs, I can take a look at the logs here, and I can see that it created a new Docker image and pushed it out. It compiled it and pushed it out and it was successful. It took 26 seconds, right? So you can see that the build job completed for the first one. And then the second one was basically, this was a node.js Docker. So second job was the deploy job. And you can see the log for that one as well. And here it's basically redeploying that application into my node pool. So it is successful. It took 29 seconds. So let's hope that this has gone through fine. Now, if I reload this application, what will happen is you'll see the new application deployed. There you go. I had changed the logo, and I also changed the name from A1 Sales to A1 Sales Store, right? So you could see both those applications have been both those changes have been picked up and redeployed. So that was my quick demo. And in fact, if you want to, one other thing which I want to show here, I talked about it earlier in this presentation, is the Cloud Shell. You can always use the Cloud Shell to work quickly with your Kubernetes cluster, right? So use the Cloud Shell, set it up with the kubeconfig file, and you can access the Kubernetes cluster relatively quick and easy. So it's taking a bit of a time here. I guess let's see. But yeah, Cloud Shell, once it is set up, you can do, you can have your small little build environment inside the Cloud Shell, which is easy to access irrespective of whether you have your local machine or your local development environment with you or not. While it's coming up, let me show you the container registry. Container registry is where our Docker image files are stored. In this case, I have the Docker repository here, and I have you can store the images here, right? So my Docker registry in this case is not in the same Ashburn region. That's why you're seeing 0 files. I have it set up my Docker registry in Phoenix region. So if I go to the Phoenix region, I should be able to see my Docker container registry and the Docker image files that I just pushed out. But here's a Cloud Shell. You can easily run all your kubectl commands and managing your Docker Kubernetes environment from here. So if I say kubectl get nodes, I should be able to see all the 6 nodes from the 2 node pools that I have. So these are the 6 nodes, and they're running version 1.16.15. So that was a quick demo of the CI/CD and how you build and deploy applications using Oracle Kubernetes Engine and the Oracle CI/CD tools. So as a recap, I had a node.js application already deployed and running in Kubernetes, connected to Autonomous Transaction Processing Database. I had the source code for that application in Visual Builder Studio. I made a small local code change as a developer. I made a code change in my local repository. I pushed out the code change to the CI/CD tool chain, and I had a step there to, as soon as the code change happens, build a new image and build the new image. I don't have a test step in the demo, but you can have a test step as well. Push that image to Cloud Infrastructure Registry and then deploy it into the Kubernetes environment, and you can see the application, right? So I hope you found that useful. So we have this was an introductory session on building and deploying cloud native applications. We have a whole set of events for you lined up, which will go into even deeper dive into some of the concepts that I talked about today. For example, we have a session set up for where's that one? Here, serverless applications, building message-driven microservices using Monolith and Micronaut, and then application continuity for developers. You can see the updated schedule here. This image is slightly old, but we have a series of webcasts coming up for you, which will go into deeper dive into some of the concepts that I talked about today, in the introductory session of Cloud Native Application Development. Here are some additional resources for you. We have tutorials, we have Solution Center, hands-on labs available for you. And in case you have questions which we cannot answer today, feel free to post them to cloudcustomerconnect.oracle.com, and we can take them and answer them there directly if you are not able to get to them today. I think we only have about 3 or 4 minutes left, but we'll be happy to answer your questions, the ones which we cannot get to today. We also have a cloud free tier, and there's a URL in the bottom of this slide, which you can use to set up your cloud trial account. You get a set of always free services with the cloud free tier, and you get some services which are free for 30 days, or you get credits for 30 days for using those services. And all the services that I talked about today should be available in the cloud free tier for you once you sign up. And with that, thanks for taking the time again. I hope you learned something or found this session useful.
Thank you. Well, with that, we will conclude. I just wanted to reiterate that this webcast is being recorded and we'll make it available in the next couple of days. If you have any questions after the session is over, feel free to contact Manish directly. And we appreciate you attending this webcast, and we hope you have a great day.